So in this video, I will briefly talk about some of the integration rules we have so far, and then I'll go over 3 examples. So we have the basic integration rules. If you have a constant multiple, you can bring it out of the integral. Um, the integral of a sum is the sum of the integrals. We have the power rule, and we have some of the rules that we talked about at the beginning of this semester. Then we have some rules that we know from calculus for the trigonometric functions, and some of the new ones that we looked at. And then finally, here, 18, 19, and 20, that's basically theorem 5.19 that we already did a few examples with. So it is important that you know when you can apply these rules and when you need to leave these rules alone. So that's what we'll do a few examples of. So the first integral we're going to look at is the integral of 1 over x times square root of x squared minus 1 dx. And if you take a good look at it, you'll see that this is an example of rule 20. So what you see here is you see your variable squared, and then minus the constant squared. So example 5 is just rule 20, and we have that u equals 1, or sorry, u equals x and a equals 1. And so when we do the antiderivative of this, you see that matches up. Our answer will be 1 over a, 1 over 1 arc secant of the absolute value of u over a plus c, and we had a is 1, u is just x, and a is 1. And of course, that can be simplified to just the arc secant of the absolute value of x plus a constant of integration. Now, for example 6, we're asked to find the antiderivative of 1 over square root of x squared minus 1. So when you look at this, you may say, okay, I don't see the variable in front of it here, but I do see the square root and I see the difference of two squares. So you may be tempted to apply rule number 18. But rule number 18, it says the constant squared minus the variable squared. And what we have here is we have the variable, and then we have the constant. And since it's subtraction, we cannot just flip those two, right? 3 minus 5 is not the same as 5 minus 3. If it had been addition, it doesn't matter what order they show up, because 3 plus 5 is 5 plus 3. But here we have a variable and a constant, and rule 18 has the constant squared minus the variable squared. So what we need to see here is that rule 18 does not apply. And at this point, this is not an integral that we can solve. Now, later on in chapter 8, we will be able to show that this integral is ln of square root of x squared minus 1 and then plus x plus c. And the way we find that integral is by a method called trigonometric substitution. So don't try to do this with rule 18, 19, or 20. These do not apply here. And then I'll quickly do one more example. The integral of x dx over square root of x squared minus 1. So again, here we have x squared minus 1. And so we have a variable squared minus a constant squared. That's what we have here. But the x is on top, not on the bottom. And so again, 20 might look like it applies, but it does not because the variable is in the wrong position. However, we can solve this using calculus 1. So what you need to do here is a substitution. So we're going to let u be equal to x squared minus 1. And then we have du dx. The derivative of this is 2x. So du equals 2x dx, or 1 over 2x du equals dx. And so with that substitution, our integral becomes the integral of x over square root of u. And then the dx here becomes 1 over 2x du. And so the good part here is that this let's undo that. I was going to take a look at the x's. This x here cancels with this x here. And so then we have an integral that's just in terms of u. So then I get 1 over, I'm going to rewrite square root of u as u to the power 1/2 du. And in order to use the power rule, I'm going to take that out of the denominator, put it in the numerator, and that will make the power negative. And so by the power rule for integration, I have to add 1 to that power and then divide by that new power and then add a constant of integration. So what that then becomes is, and I notice here that I forgot about the constant 1/2 here. So I have 1/2 here. And that 1/2, that cancels out with the 1/2 in the denominator here. And this becomes u to the power 1/2. Right? That's u to the power 1/2 plus c. And that's the same as square root of u plus c. And then finally, we had u is x squared minus 1. So this is x squared minus 1. And then plus c. And that is our final answer.